Yes, student, very good evening. How are you all? Sir, we are good. What about you? If you are good, I am also good. Now, in today class, we are going to see the very important part of the topic, and this is the very important part. Over there, every exam question coming, very good and easy part. The name of the topic is called hydrogen bonding. What is the name of the topic? Hydrogen bonding. Today we are going to start a very important topic, and the name of the topic is called hydrogen bonding. And this is that much important and that much easy also. Now, what is hydrogen bond? Rule is that suppose any place you have some element X, that X will be either fluorine or oxygen or nitrogen. X will be either fluorine or oxygen or nitrogen. That X is attached with some hydrogen. It means either fluorine with attached with hydrogen, or oxygen is attached with hydrogen, or nitrogen is attached with hydrogen. Then there will be one Y. Y will be also fluorine, oxygen and nitrogen. Either here you will put fluorine, or here you will put oxygen, here you will put nitrogen, or any place you can put. Means, understood the logic what I am trying to say. Hydrogen bond will form only and only whenever there is X. That X will be either fluorine, oxygen or nitrogen attached with hydrogen. Another compound, another element is there Y. That Y will be a fluorine, oxygen and nitrogen. What happens? Ki fluorine, oxygen and nitrogen are highly electronegative. They are highly electronegative. Because of that, they will try to attract the lone pair of electron towards itself. As it is trying to attract the lone pair of electron towards itself, so it will get del negative charge and it will get del positive charge. Here del negative, del positive. Here del negative, del positive. Here del negative, negative charge will attract the electron towards itself. So del negative, del positive. Now this positive charge will be seen by fluorine, oxygen and nitrogen, that is Y. So this Y is more electronegative, try to attract towards themselves. So over here they will form a bond, and that bond here also form a bond, here also form a bond, and this bond is known as hydrogen bond. Understood the logic? What is hydrogen bond? This is basically the hydrogen bond is there. Now after knowing the hydrogen bond, some example I am going to write and dictate you how the hydrogen bond is formed over there. Suppose I have taken water as a liquid. Sorry, water as a liquid. Over here, what happens? Water H2O. We know that water has a formula H2O. H2O. Then another HOH. Then another HOH. Now oxygen, it is Y. If you will consider, it is Y. It is X, and over here H. It will get del negative positive. It will get del negative. It will attract here hydrogen bond. This is H bond. Similarly, over here it will form H bond. Like that, lots of water molecules will come, and so on. Hydrogen bond is going on. This side also, so on. Hydrogen bond is going on. They will ask how many water molecules needed to form a hydrogen bond. That is called coordination number. That is 2. Sometimes they will ask this question. What is the coordination number? CN means coordination number. Or sometimes they will ask you number of water molecules. So how many number of water molecules required to form hydrogen bond in water as a liquid? 2 water molecules. Minimum 2 chahiye na? Minimum 2 required. If it is not there also it will form na? But it is there, no problem. But minimum 2 is required. Minimum. This is minimum. Minimum 2 is required. Acha. So first we have seen hydrogen bond in water. Similarly, example by example we will understood. Second, we have to see same water we have to take, but this time I have taken water H2O as ice. Not previously I have taken water as liquid. Now I will take water as a ice. What happens? Ice will be something like that. Water has one lone pair here, one lone pair here, one hydrogen, one hydrogen. Another side hydrogen will come, oxygen, water. Another side, oxygen will come, hydrogen, hydrogen. Another side, oxygen will come, hydrogen, hydrogen. Another side, hydrogen will come, water has H2O, no? So this is there. Now, this will also form hydrogen bond. These are hydrogen bond, dash dash. This is also forming hydrogen bond. So, you have seen that whenever ice is formed, this empty space will be there. Because of this empty space is known as void. And over here, minimum how many water molecules required to form a hydrogen bond to the compound will be ice. So 1, 2, 3. 1 to water molecules is there already. How many required? 1, 2, 3 and 4. Sir, why you have not counted middle one? Middle one to water molecules is there. Surrounded atom. Oh, surrounded over here, surrounded atom. Suppose you will take this middle one. Surrounded atom 2 is required. Similarly, you will think over here. What is the coordination number over here? 4. How many surrounded water molecules is there? 4. So we will have 4 coordination number to form a ice. So whenever you are seeing it, the density of ice is less than water and volume of ice is greater than water, because density is inversely proportional to volume, because density equals to mass by volume. It means, so ice will float on water. Ice will float on water. Why ice will float? Because over here empty space is there. This empty space will allow the ice to have a less density. Water does not have an empty space. So first type of question they will ask, how many number of water molecules required to form ice? 4 number. That is coordination number 4. How many number of water molecules required to form water molecules? Water liquid as a hydrogen bond. 2 molecules required, coordination number 2. And why ice will float on the water, understood. And whatever be the example I am going to take, more than that example you didn't have to study for hydrogen bond. Fixed example is there. The first we have seen water as a liquid. Second we have seen water as a ice. Third we have to see hydrogen bond in HF. It is forming like a zigzag. HF. Here again another H will come, F. Here again another H will come, F. Here again another H will come, F. And so on, it will be go like this. Here also it will be go like this. And this is known as, over here, if anybody is asking what is the angle over here coming. So this angle is greater than or equal to 120 degree and less than or equal to 140 degree. Sometimes they are asking angle also. This is the hydrogen bond in HF. Only in ice and water they will ask coordination number, means how many water molecules required. Remaining other places they will not ask about the water molecules or how many HF is required to form a hydrogen bond. So this is the dot is hydrogen bond over here. So I hope you understood the hydrogen bond in ice, water, liquid water and HF. Similarly, like that fixed example, what I am dictating, that is the fixed. More than that, never the question will come. Next example we will have question is ethanoic acid. Ethanoic acid. Ethanoic acid is also known as acetic acid. And acetic acid has a formula CH3COOH. Now, it will acetic acid will always form dimer. What do you mean by dimer? Means agar 2 combine together to form 1, A2, it is known as dimer. If 3 combine together to form 1, A3, this is known as trimer. If 4 combine together to form A4, that is known as tetramer. That is known as tetramer, like pentamer, hexamer, heptamer. I am saying ethanoic acid will always form dimer. It means ethanoic acid, how it will form? Check. CH3, C, double bond O, O, H is there. Means like that you will draw. It is easy to understood. I can draw ki double bond O and OH is there. This formula can be represented like this. Dimer means another will come. CH3, C, double bond O put there and OH put here. What will happen? over here oxygen and this, because X H Y there na, rule is that na, X H Y first rule. So here hydrogen bond, here hydrogen bond. It means if you have to form the hydrogen bond of acetic acid, you have to take 2 mole of acetic acid. It will combine together to form CH3COH whole twice, and this situation is known as dimer, someplace written dimerization. Dimerization. So don't get confused over here. This is the hydrogen bond in ethanoic acid. How many we have to study? Some more. And don't worry, what I am saying, that is the fixed number of example. More than that example you will never see. So just revise each and every example. Next example we have to see the hydrogen bond in potassium hydrogen carbonate. Formula is potassium means K, hydrogen means CH, carbonate means CO3, KHCO3. Ab now KHCO3 will break as HCO3 1 minus plus K. If you will draw the structure over here, what you will get? HC double bond O, not HOH will come. Wait. Structure is C double bond O minus, how many OH is there? 3. So this is the structure of HCO3 minus. Fixed example I am saying, don't get confused. How it will draw? Draw it. C double bond O, this structure I am drawing like this. This side O minus, this side OH. Similarly this side C double bond O, this side OH and this side O minus. What will happen? Here it will form the hydrogen bond, here it will form the hydrogen bond. So this is the design of hydrogen bond in potassium hydrogen carbonate. Done. First example, practice once, you will get it. Understood the point? Now, next question. Next question we will have is the hydrogen bond in sodium hydrogen carbonate. Sodium hydrogen carbonate is NaHCO3. There is no difference between these two, but hydrogen bonding is different. Potassium hydrogen carbonate has a hydrogen bonding like this, because potassium hydrogen carbonate is always found as a solid, and sodium hydrogen carbonate is also found as a solid, but when it will break as a Na plus HCO3 1 minus. It will also breaking like that, but their hydrogen bond is like this, and their hydrogen bond is O, C double bond O minus, H, O, C double bond O minus, so on, and this is the hydrogen bond. It means whenever sodium hydrogen carbonate, hydrogen bond is like a circular structure, but whenever potassium hydrogen carbonate, circular structure. Sodium hydrogen carbonate, straight chain. Understood the point? So these are the fixed example. You have to practice 1 to 2 times you will practice, or 1 to 2 times you will see the video. Automatically fixed number of example, fixed number of question. Rather than that, no any question will come from this. So don't be worried about it, sir. If they will ask anything extra, what I will do? No, I am sure that they will not ask anything extra. Next question. Alcohol in water. Alcohol has a formula ROH, and water has a formula H2O. What happened? O, one side R, one side H, over here HOH, and here it will form hydrogen bond. If you want, you can do opposite also. This oxygen, anyone will say, sir, I want to draw like this. Draw it. H, this side you will put OR, and for water, O, this side you will put HH. This is also hydrogen bond. H bond. Rule is that X is attached with H and Y will be there, and that X will be FON, fluorine, oxygen, nitrogen, and Y will be fluorine, oxygen, nitrogen. Understood the point? So, due to hydrogen bond, alcohol is soluble in water. 90-90 baking, na? Soluble in water. This is the reason for hydrogen bond to be there in alcohol with water, so it is soluble. Now, next example is boric acid. Boric acid. Boric acid has a formula H3BO3. Their structure will come BOHOH. In this part, this is our boric acid. This is our boric acid. ओरे पिया है उड़ने लगा क्यों. हाँ, this is our boric acid. This is what happens. This will form the hydrogen bond with other boric acid. This will also form the hydrogen bond from here. This will form the hydrogen bond from here. This will form the hydrogen bond from here. This will form the hydrogen bond from here, and this will form the hydrogen bond from here. Understood the point? So this is whatever be the example I have taken up to now. All the above example is a example or is an example of intermolecular hydrogen bond. Intermolecular means two different compounds. See, whenever I am taking water, only one molecules of water is not there. No? Lots of molecules of water as ice, lots of molecules of water as a liquid, lots of molecules of HF, lots of 2 molecules of ethanoic acid, 2 molecules of hydrogen carbonate, 2 molecules of sodium hydrogen carbonate, 2 molecules, one is alcohol, one is butter, boric acid, another molecules I have to take each and every places here. So over here they are known as inter, means different matlab two molecules is coming and combining together to form a hydrogen bond, and this is the example of intermolecular hydrogen bond. Now I am going to dictate you intramolecular hydrogen bond. In that only one compound will form the hydrogen bond. Two compound is not required in this. Sir, example give. Intramolecular hydrogen bond is something like this. Suppose I have taken first example, ortho nitrophenol. Over here, if we will see, this is our benzene ring and ortho nitrophenol OH, and over here NO2. If you will draw their structure properly, what you will get? Sir, over here O, over here H, and over here N, double bond O, coordinate bond O minus or direct O minus. Now over here, does you need another type of nitrophenol? No. Over here in the same compound they are making only one compound. Orthonitrophenol is only one compound. Na? You are not over here. What you have done? Boric acid, another boric acid, alcohol and water. Over here sodium hydrogen carbonate, two sodium hydrogen carbonate you have taken. Over here 2 ethanoic acid you have taken. But in this part you have only taken only one compound, orthonitrophenol, and it is forming hydrogen bond, and these types of hydrogen bond is known as intramolecular hydrogen bond. Same compound is forming the hydrogen bond is known as intramolecular hydrogen bond. So sir, more example? Yes. How many perfect example is there? All the example I will give, don't worry. Second example we have is ortho. O means ortho salicylic acid. Fixed example, again I am saying, don't get panic. Ortho salicylic acid has a structure OH and over here COOH. If you will draw this structure very properly, what you will say? Sir, over here OH and over here C double bond O, OH. Over here same compound is forming hydrogen bond. Other more orthosalicylic acid is not required. This is known as intramolecular hydrogen bond. Suppose I will take the another example, third one, that is known as orthosalicyldehyde. Means this example you have to learn. Trust me, it is not about which one of the following will show. Every example I am dictating. Every example, how much example is required, I am dictating all. More than that, there is 0.001% chance that it will come. This structure here, it is forming hydrogen bond. So this is orthosalicylic acid. Now another one we have to check. Fourth one is the anion malic acid. Anion malic acid. Anion malic acid means malic acid formula is this: CH double bond CH COOH COOH. First make the anion of this. If you will make the anion of this, what you will do? One hydrogen you will remove, minus will come, means CH double bond CH, over here COO minus, over here COOH. If you will draw this structure very properly, what you will get? CH double bond CH, over here C double bond OO minus, over here C double bond OOH, and in this part minus O and H is forming hydrogen bond, and this is formed by only one compound, so it is also known as intramolecular hydrogen bond. Next example. कभी कभी सुपर मच्छी, अरे सुपर मच्छी. Fifth example. Fifth example is fixed example. I am saying fixed. More than that not coming. Anion of Carose acid. Carose acid. Sir, we have to learn it. Yes, definitely. And it is very important. H2SO5. Structure HOS double bond O OOH. Now you have to make the anion of this. What you will do? Remove hydrogen, make negative. What you will get? A structure S double bond O O minus OOH. I am going to just manipulate this structure like this: S double bond O, one side O minus, one side OOH, and this is forming hydrogen bond. And this is also formed by only one compound, so it is known as intramolecular hydrogen bond. So intermolecular hydrogen bond and intramolecular hydrogen bond, all the example I have completed. If you are not understanding, please try to see it once again. Now some special cases of hydrogen bond. Sir, why I have written special cases? In the beginning what I have dictated, कि only hydrogen bond will form when X, H and Y. X will be FON, Y will be FON. Means fluorine, oxygen, nitrogen, fluorine, oxygen, nitrogen. But some special cases are there. If fluorine, oxygen, nitrogen is not there, still it will form, and they are also fixed. First one is acetylene plus acetone, CS3 C double bond O CS3, that is acetone, and acetylene means C2H2 alkyne. What you will do? HC triple bond C and H, and over here C double bond O and CH3 CS3. This structure I have drawn like this. Now you will say, sir, this triple bond is sp hybridized, more electronegative, so it will take electron, this will get del negative, this will get del positive, and over here oxygen is there, so it will also form hydrogen bond. Understood? Next example. This is a special case example. Second example. Understanding na? Second example is chloroform. CHCl3 is known as chloroform plus acetone. Chloroform plus acetone. Chloroform C, Cl, Cl, Cl and H is there. And over here acetone, just now I have written double bond C, CS3. Previous example acetone only. CS3, C double bond O, CS3. This structure I have designed like this. Now chlorine is more electronegative, it will take the electron. So because of that carbon will also take, automatically it will get del positive, it will get del negative, and here it is forming hydrogen bond. Understood? Next example is the example of orthochlorophenol. Orthochlorophenol will also show hydrogen bond. How, sir? Over here OH and over here Cl. A special example, I have written some special cases. This is also forming hydrogen bond. Hydrogen bond. How many example is there? Just little bit more. After that question will be done. And each and every example you have to learn. You have to understand which of the following will show. You have to see it very properly. Fourth example is the example of chloral. Chloral has a formula CCl3CHO. What will happen? Chloral has C, Cl, Cl, Cl. Then CHO, C, CHO, C over here, O, H, over here also OH. Now after seeing it, you will say, sir, this is the CHO. CHO is C double bond OH aldehyde. No, written like this, but their molecular formula is coming like this: C2Cl3 OH2O2. This structure is like this. Structure is like this: Cl, 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 OH, OH. This is the structure of chloral. But sometime written like this. So written like this, don't get confused. So over here hydrogen bond, and here hydrogen bond. Someone will ask, how many membered ring is formed over here? So 1, 2, 3, 4. Sorry, over here also Cl. 1, 2, 3, 4, 5. This is forming 5 membered ring. And this is also forming 5 membered ring. It means you will say chloral has 2 5 membered ring. How many membered ring? 2 ring is there, that is 5 membered ring is there in the chloral. And a structure, this is bond, here also bond. This structure you have to learn. Formula is written like this, but the structure is different. Yes sir, something is there that you have to know. Understood? So these are the all example regarding hydrogen bond. Now little bit more we have to study about the hydrogen bond. What we have to study? That is, example done. Strength of hydrogen bonding. How we will know that hydrogen bonding is stronger? So I have told you X, H and over here Y. If X is oxygen and nitrogen, so oxygen has more than nitrogen, and Y is nitrogen more than oxygen. Understood the point? A fluorine is always more. For fluorine, no doubt. It means, suppose I will write OH and over here I will write N, and it will form hydrogen bond. And over here I will write NH, and over here I am writing O, and it is forming hydrogen bond. I will ask, which hydrogen bond is more stronger? So you will say, this is a stronger hydrogen bond. It means in XH, oxygen will be there more and nitrogen will be there, then it will form the highest stable hydrogen bond, except fluorine. If fluorine is coming, that is the most electronegative. Understood the point? So this is the strength of hydrogen bond. Just see it once. If question will come, you are able to do it. Any problem is that? It means, what I will write, ki check first X, this X theory I am writing, and in any one of them is F is there, then it has more stronger. Means if either X is F or Y is F, then no need to check, that will be the most strongest. But if F is not there, F is not there, then check oxygen or nitrogen, nitrogen, oxygen. Understood the point? If any place either X will be F, suppose X is also F, Y is also F, then strongest. X is F, Y is N, also strong. X is N, Y is F. F coming, strongest. If F not coming, oxygen or nitrogen only coming, then check like this. This is the priority order. Now understood this? Now some more part of the topic, then this topic will be completed. We have two parts of hydrogen bond. One is known as inter, one is known as intra. If I am talking about boiling point, if I will talk about melting point, these are very important. What I am writing, it is very important. Sometimes they will ask directly from here. I am writing about solubility. I am writing about vapor pressure. Now what will happen? Inter, at least two compound needed to form an inter hydrogen bond. तो ऑब्वियस सी बात, एटॉमिक वेट इंक्रीजेज, मॉलिक्यूलर बॉइलिंग पॉइंट इंक्रीजेज, इंट्रा ओनली वन कंपाउंड फॉर्मिंग तो डिक्रीजेज, मेल्टिंग पॉइंट ऑल्सो इंक्रीजेज, इट इज डिक्रीजिंग, solubility also increasing because two alcohol is forming the hydrogen bond with water, so soluble, it is already forming a hydrogen bond, why it will go into the water, only vapor pressure is opposite, yani each and everything in inter is more, boiling, melting, solubility, but vapor pressure is more in intra than inter. Sometime they will ask which one is more volatile, which one is more volatile. Volatile means easily evaporate, easily evaporate, and which has more vapor pressure, intra. So intra is more volatile than inter. If any place more volatile question asking, check which one is forming intramolecular hydrogen bond, that is more volatile. Over here more volatile you will write, or that can also written sometime steam volatile, so don't get confused, volatile, steam volatile. So what you will write, intra is steam volatile, very hardly you will do, understood the point, sure short. Acha. Now if sometime they will ask bond length, bond length, which has more bond length, so hydrogen bond has more bond length, hydrogen bond has more bond length than covalent bond. Why sir? Hydrogen bond and H dash dash O, this much gap, covalent bond this, तो obvious सी बात कि bond length of hydrogen is more than covalent bond. If they will ask you H2O is given, another example, everything I am writing this you will consider as a learning part. H2O is given, D2O is given, asking more boiling point. What you will say कि sir H2O has less boiling point than D2O, D2O has more boiling point. Why sir? Because if you will make the hydrogen bond, what you will get, H hydrogen bond HOH, and D2O you will make, what you will get, ODD hydrogen bond DOO. Now it is became negative, it will become positive, so D is heavier, it will become negative, it will become positive, H is lighter, so D is heavier, D is heavy, so it will create more positive, and if it will create more positive, so more positive, more attraction, more stronger hydrogen bond, more stronger hydrogen bond, more boiling point. Understood the point? Sure short everyone. Suppose I am going to dictate you some more question, then this topic will be done. Sir, from that time you are only saying some more question, still you are dictating it, don't worry. Now suppose one, I don't want to miss any part of the topic. Suppose one question is coming about solubility. They will ask which one is more soluble. First they have given CH3CH2OH, and second they have given CH3CH2CH2OH. Which one is more soluble? So understood one thing, if alkyl group, R means alkyl group, is increases, then solubility decreases, over here 2 alkyl group, over here 3, so which one is more soluble? This one is more soluble. Understood the point? Sure short. Last part, in 1987 advanced they have asked this question, so I am writing this over here, but not that much important, that ice is capable of forming Clathrates. This is directly learning. Clathrates is made up of helium and neon. Take ice is capable of forming clathrate, helium and ice is capable of forming clathrate. Ice is capable of forming clathrate. First important point, clathrate. Second important point, helium and neon, not forming clathrates due to a smaller size. Understood the point? So suppose they will ask you the question, and the question is, how to distinguish between helium and argon. So what you will say? Helium will form, not form clathrates, and argon will form clathrates. That's it. So those who will form clathrates, they are argon. Those who will not form, they are helium. Now some of the student will say, sir, this the too much example you have written. What I will do? I didn't understood. Don't say this ki not understood. Just learn it and try to do it, because fixed example I have given, and I hope I have tried and don't want to repeat it. Sometime repetition will decrease the concentration, so I am dictating in one time 35 minutes. Bye, have a nice day, enjoy, take care, stay home, stay safe.